Okay, so good evening, everyone. As you already know, my name is Rahul Kumar, and in this live session, I'm going to give the lecture of engineering mechanics in week 3. Okay, so in this week, I will talk about trusses. So let's move on the one note. But before going to week 3, in the last class, I gave you some homework. So are you guys able to attend those or not? Hello? Hello?
Yes, sir.
So, have you guys tried or not?
Uh, Actually, sir, I didn't attend the last class, therefore I
Uh,
I wasn't aware about that problem. I missed.
okay, okay. It's fine, but I think you should try. Okay, otherwise there is no point of discuss to all these things. Okay,
Actually, sir, I wasn't aware about that problem. Actually, I was
okay,
unable to attend due to my exam.
okay. It's fine. So, okay. I will I will try to solve. Okay. Have you guys uh have you guys saw at least those problems? Hmm?
Yes, sir. Before that, I practiced those kind of problems, sir.
Okay, okay.
Before attending this lecture.
Okay. Actually, in the last class, I gave you this problem. Some people were saying that, sir, in the GATE exam, I only marked only one option, that is option GH. But some people are saying that in the GATE exam, there are two answers of this problem. Okay, so let's solve this problem, and we'll try to identify okay how second options how second option is coming. Okay, okay. Uh, so I have already talked about that. If there is a link, okay, like this. So these links are only one. I mean two force member, and all those forces are only along the axis of the link, because at the end of the link is actually pin joint, so it is not able to resist the moment. That's why this link is able to only resist the axial force. Okay, so that's why if I create FBD of this frame, because I think first I should say just read this problem. Okay, then I will discuss, because otherwise you will not to able to understand. I'll give you 1 minute and just read the problem. Okay, so
Sir, at G there would be no load or no workload or no force would be act. So therefore that would be zero, sir.
yeah, at the end the member GH, it is straightforward. That is the force in the member GH is 0. Okay, and
Yes.
but the problem is there is one more option where in which there is one more zero force member is also there. Okay, let's find how it is possible. Okay, so first I will create FBD of this frame. Okay, so this frame is like this, and I have already told you that all these links are able to only bear axial forces. Okay, so suppose this force is FCD and this force is FEF, this force is FAB, and I have already told you that this member, I mean this link, is also only apply an axial force, that is FGH. Okay, and there are two more forces, that is Q and Q here. Okay, so here FGS is definitely 0 because if you resolve FGS into two components, that is I mean in the perpendicular direction, that is FGS, because here angle is 45 degree, right? Because all members are equal length. So okay, so this angle is 45, so FGH cos 45 degree, and here FGH sine 45 degree. Okay, now if we apply equilibrium in this direction, okay, so what will be the equation? FGH cos 45 degree, and there is no another forces, okay, apart from this force, so it will be equated to 0 because by the summation of F in this direction, suppose axes are along this like this, so you can say that summation of Fx will be 0. So there is only one force in this direction, okay, so FGH equal to 0. Okay, so this is the straightforward. Okay, now I will talk about another forces. Now I can easily remove this force. Okay, now I will create another FBD such that we will not show any force of GH. Okay,
Excuse me, sir.
yeah,
Sir, actually, whenever we have a slot, it will be along the slot, no, sir, the reaction.
yeah, it doesn't matter if you still try to solve this problem by assuming that the force will be along only in the direction of perpendicular to the slot, then still you will achieve the same result. You know, it doesn't matter. Actually, I generalize the thing. Are you able to understand? I've actually generalized the thing. Still, you are getting the same thing. I mean, FGH will be 0. Okay, if you still consider that the force we will show along the direction of perpendicular to the slot, okay, still you will get the same result. It doesn't matter.
Yes,
Okay,
sir, but like I'm just asking how we'll draw the FBD generally, sir, just to
okay.
avoid this.
Actually, if you try to draw the FBD in general, suppose you want to try, you want to draw the FBD. Okay, what will you do? You will do like, suppose I am not assuming that this is a link. Okay, so what will you do? You will do like this. I mean, yeah, you will do like this. Suppose that the force, one force is in this direction and another force in this direction. Okay, F1 and F2. Okay, still F2 is 0. Still F2 is 0 because there is no force to there is no force to balance to this force. Still you will receive the same result. It doesn't matter, right? It doesn't matter because anyhow you have to apply the equation of equilibrium, okay, and you will receive the same result. It doesn't matter. Okay,
Yes, sir. So actually, I can you kindly explain this why we got FGH 0, sir?
FGH is 0 because suppose I'm trying suppose according to you, suppose I will go in this direction, right? I will try to solve the problem by this FBD. Okay, what will you do? What will you do? Still in this direction, if you write the equation of equilibrium in this direction, then what will you write? Summation of, according to this convention, what will you do? Summation of Fx equal to 0, then F2 equal to 0. Okay, what? If F2 is 0, now write, write the FBD of GH. Okay, so what will you do? Here you will write FBD F2 like this, and suppose F1 is something else. F1 is something else. Okay, right? F1 is something else. Now resolve this problem. Here F2 is already 0, right? Here F2 is already 0. There is no meaning to write this F2 force. Now resolve F1. If you resolve F1, you will achieve the situation that, suppose the angle is here, angle is 45. So what will you do? Resolve F1. So here F1 cos 45 degree and F1 sin 45 degree, right? Tell me.
Yes, sir.
Yes,
Yeah,
sir.
yeah, still you are achieving the same result. I mean, here also F1 is 0, so there is no force here.
Okay, sir. So, but what if we are able to uh, resolve these forces into two components? So that these Q are there.
What?
We have these Q forces, no, sir? Q forces FAB,
Yeah, yeah,
FGF.
yeah. First, I will try to convince you that FGS will be 0. Now, I'm going to draw the FBD when there is no force of GH. Okay, so what will you do? Like this, right? Okay. Now apply moment equilibrium about this point. Okay, at any point you can apply the moment equilibrium. Okay, now apply the moment equilibrium about this point. What will you do? Suppose here the length is A, so he will be there A by 2, that will be A by 2. Okay, by the summation of horizontal forces, by the summation of horizontal equilibrium, what will you do? You will do Q plus FAB equal to what? 0, right? By the summation of fx equal to 0. Now apply summation of fy equal to 0. So what will you do? fcd plus q plus fef equal to 0, right? You have two conditions. Here you have achieved fab equal to minus q. Now apply the moment equilibrium about this point. Okay, if you apply the moment equilibrium about this point, you will achieve fab into a. Okay, and the moment is in this sense, plus q into a by 2, okay, minus q into here also a by 2 minus fef into a equal to 0, right? So this will be cancel out, right? So fab equal to fef, right? Tell me. FAB equal
Yes,
to
sir.
FEF.
Yes.
Now here FEF, now substitute here FAB equal to what? Minus Q. So FEF equal to what? Minus Q. Now substitute this result here. So what will you achieve? FCD plus Q and FEF equal to what? Minus Q equal to 0. So FCD equal to what? 0. So still there is one more member where force is 0, and that member is nothing but the CD member. Okay, that's why result will be GH and CD. Are you guys able to get it? Tell me.
Yes, sir.
Yeah. Is there any problem here to understand?
Sir, actually, this GH part is a bit difficult for me.
GH, why it is difficult? I mean, it is a link, right? It is a link, and there is only one force which is directly along the direction of the link. Okay, so if you resolve in these two direction, I mean FGH cos 45, FGH sin 45, and here for balance to balance this force, there is no force. I mean, if you apply the equilibrium in this direction, so what will you write? FGH plus cos 45, and there is no another force, so you have to equate it to 0, so you will get the result FGH equal to 0. So what is the problem here?
Sir, actually, if we can take the component of Q in the direction of F cos 45, no, sir.
What?
FGH cos 45.
uh
Because usually we will say that there is no component whenever two forces are perpendicular. But here we have Q which is not perpendicular to FGH cos 45.
Q is I'm not getting what you want to say.
Sir, actually, if we are taking the FGH cos 45 component,
Yeah.
um, won't it be balanced by a component of Q?
Oh, yeah, yeah. Actually, this Q, this Q force is in this member, right? Not here. Okay, you have to understand this. This Q force is on this member, not this member. Okay, so what is the meaning to balance this force with Q? There is no meaning. Okay,
Okay,
Q,
sir.
yeah, Q force is in this member, and this Q force is on this member. Okay, not in this member. Okay, so don't confuse with this. Okay.
Sir, can we say in this manner BG and G manner are collinear, so GH will be zero force member?
Yeah, yeah, that result you achieve by this thing. Okay, that result you always achieve by this thing, because anything, suppose you have FA. So what will you do? Suppose the angle is theta. So here F sine theta. Okay. Here if you resolve the force FA, so what will you do? If you resolve the force FA in two directions, one direction is the perpendicular and one direction along the tangential. So by writing the equilibrium equation in this direction, what will you do? F sine theta equal to 0. So you will receive the same result by equating the equilibrium equation by by writing the equilibrium equation in this direction. Okay. So don't just remember results. Okay. You have to understand also. Okay.
Yes, sir.
Yeah. In the next problem, I talked about this, and I asked you, can you determine the all reaction forces in this problem? Have you guys tried or not in the last class? Tell me. No, right?
No, sir. Sorry.
Yeah, okay, don't worry. Just go to my previous lecture on my YouTube channel, and I told you, I asked you to solve this problem. Okay, so don't worry. Just revise the previous lecture and try to solve this problem. Okay, so for now, let's move to the next topic, that is trusses. Okay, so what is trusses? Someone can
Sir,
define.
basically the structure to carry loads.
Okay,
Take axial loads.
what? Please repeat.
Take axial loads only.
Tangential load. Okay, let's move. Okay, so trusses which are designed to support loads and are usually excuse me, can you please give me 1 minute? Actually someone is at my door. Okay, just I'm coming for a minute. Yeah, okay, so what I was writing, trusses which are designed to support load and are usually stating stating fully constrained structures. Okay, so trusses are designed to support load and usually stating fully constrained structure. In the last class I talked about constraint things. Okay, and the second point, it is saying it is a member. Okay, it is a member of trusses. Trusses are actually two force members, two forces member. Okay, that is two equal and opposite forces are acting. Okay, two equal and opposite forces are acting along the member. So okay, so this point is actually very important. Now the third point is member in trusses are joined together by welded, bolted, or riveted. Okay, riveted. Therefore, the force acting at each each end of any member are assumed assumed to be, okay, this point is very important, to be pinned, okay, assumed to be pinned, joint, okay, and hence forces are actually reduces to a single force. Okay, so are you able to get it, what I'm trying to say?
Yes.
Yeah. Now, so what is the target? I mean, why you are studying the trusses? So main target, I mean, what is the target? What is the target? Ah, so what is the target? The first target is to find forces in each member, right? The first target is this, okay? And the second target is what? To find reaction forces. Okay, so these are targets, okay, to study trusses. Okay, so let's see one simple truss. Very simple. Okay, suppose there is a truss such that the situation is like this, okay, and there is one more member, and there is a vertical force P, and all those members are connected by pin joint. Okay, so if we dismantle this truss member, so what will you have? You will have three members, right? One, two, three, sorry, 1, 2, 3, 4, and 5 members, and each member are either have force like this or like this, right? If you see the situation like this, then you can say that this member is in actually compression. And if you see the situation like this, then you can say that this member is in tensile. Okay, okay. So in solving the truss problem, you will see that there are n number of, if you see the trusses, you will see that there are n number. N is the number of joints, and there are m number of members, okay, and there are usually, I mean usually in general, you will see three numbers of what reaction forces. Okay, in general, I mean in your syllabus, you will usually see there will be n number of joints, m number of members, and three number of reaction forces. Okay, so if you see the situation, like this, if m plus 3 equal to 2n, then you can say that the system, I mean the truss system is in the truss system is in completely constrained Okay, so what is the meaning of this equation? Okay, suppose you have m number of members, okay, like this. Here 1 2 3 4 5. Okay, if you have m number of members, then definitely in each member there will be what? One force. Okay, if you have m number of members, then you will have what? M number of forces. If there are m number of forces and also there is three more unknowns, I mean those are reaction forces. Though what is the total number of unknowns? There will be m plus 3. Okay, and at each joints, if you separate each joints, then at each joints you can apply only two force equilibrium. Okay, so if there are n number of joints, then you will have what? 2n number of 2n number of equations. So if m plus 3 equal to 2n, then you can say that the number of variables are exactly equal to the number of equations. Then definitely you can say that what? The truss system is in completely constrained. You got it? Tell me.
Yes, sir.
Yeah,
Yes, sir.
yeah. Okay, so let's check this. Suppose in this situation, you have what? 1, 2, 3, and 4. 4 number of joints. So 1 joints, 2 joints, 3 joints, and 4 joints. And in this joint is connected by how many members? 1, 2, and 3 members, right? One member is like this, one member is like this, one member is like this. Suppose in this member the force is P1. Okay, so here there is a P1. If the P1 is in this member, then definitely there is an equal and opposite force is acting on this joint. So the force is P1 here also. Now this member has the force P2. Okay, then there will be equal and opposite force here also. So this pin joint will have P2. Okay, now the member here is also okay. So suppose it is a P3, then there is a force P3. Suppose it is a P4, then there is a P4. Suppose there is a P5, then there will be what? P5, and there is one member also here. And what is the 1 2 1 2 3 4, right? uh have I made any mistake? There is how many members? 1 2 3 4 5 members. Okay, right? So here P5. Okay, so here is also P5, and there is P5, and here there is a P5. Okay, and here is a P1, then there will be P1. Now in these two joints there are reaction force also, and since it is a roller joint, then there will be only one reaction force, that is R1. And here it is a pin joint, so there will be two reaction forces, R2 and R3. Now see the situation. So to solve this problem, what I want to do, what I want to find, I want to find all those unknowns. I mean total number of forces in the member and reaction forces. So how many P's are here? There are one, two, I mean 5 P's. Okay, right? 5 P's plus how many reaction forces? 3. So how many unknowns are here? 8, right? Total unknowns are what? 8. And how many joints are here? 1, 2, 3, and 4. 4 joints. Okay, 4 joints. So you have to multiply with 2, because at each joint you can apply 2 force equilibrium, one in x direction, another in y direction. So you will have 8. So you have 8 unknowns and 8 equations. So 8 equal to 8. So the system is completely constrained. Okay, so whenever you try to solve any truss problem, so first you need to check this condition. Okay, otherwise you will be in trouble. Okay, so let's move one sample problem.
Sir, if there will be two,
Yeah, yeah, what?
uh, If there will be no roller joint, only fixed joint at the two end, force of reaction
Yeah.
will be there.
So for that, I will recommend to watch my previous video, okay? Because I have already talked about all these things, okay? Okay. I think you have not watched
Yes,
the
sir.
yeah previous video, okay? So I would say that first review that video, okay? Okay. So let's see this problem, okay? First I will solve this problem, okay? Then after that we will try another. Here you have to see very careful, okay? Because here it is a pin joint, but here there is a roller joint. It is I mean rarely visible, but still you can assume that here is a roller joint, okay? So what is the situation here? How many number of members, can you tell me?
5 members, sir.
How many members?
Five.
Five. 5, right? So members are
Four.
5. Okay. So number of reaction forces are still 3 because 2 here and 1 here, right? So 5 plus 3 equal to what? 8. This is the same situation whatever I have discussed earlier. So how many joints are there? 1, 2, 3, and 4. So J equal to 4. So you have to multiply by 2. So 4 into 2 equal to 8. The system is completely what? Constrained. So now I will solve this problem. So what is the problem? The problem is find the magnitude of the force in the member BC, right? In this member you have to find the force. Okay, so to solve this problem, you can do one thing. Okay, I will discuss it when I discuss I mean the method to solve the truss problem. Okay, the first method is method of joint and the second is method of section. But before that I will first solve this problem. Okay, indirectly you can say that I will apply the method of joint. Okay, so I will not I mean repeat. Okay, so first it is, see this here, there is a force 10 Newton, 10 kilonewton, right? And the reaction force is R1 and R2. And here since it is a roller joint, so there will be only one what? Vertical force, and there is no horizontal force. And here there is a member. Okay, now we have to find the force in this member. Okay, so I have isolated this member. I mean first I have isolated the whole structure, and I will find the reaction forces. Then I will go through the equilibrium equations. Okay, so if I apply the moment about this point, I mean about point A, so the summation of MA equal to what? 0. So what will you do? Here the all lengths are same, right? All lengths are same. Suppose it is a by 2 and here it is also a by 2. So summation of MA equal to 0. So what will you write? R3 into A, right? In this sense, and minus 10 into what? A by 2 equal to 0. So what will you get? R3 equal to what? 5 kilo Newton. Okay, you have already the reaction force R3. Okay, now if you want here I have to determine the force in this member. If you want to skip to find R1 and R2, still you are able to solve this problem because there is no need to find R1 and R2. Okay, so first I will skip the I mean another equilibrium equation, and then I create FBD of the joint C. So suppose the force in this member, which member? CD. Suppose the force in this member is P1. Okay, so here P1. Okay, so if you apply, I mean if you assume the force in this member is P1, then there will be equal and opposite force in this joint at this direction, right? So there is a force P1, and suppose in this member, the member BC has the force P2. So here there is a P2 and you have to write P2 here. And since you have already determined the reaction force R3, that is in the same direction as whatever you have assumed. So you have to be very careful, okay, for the directions. Otherwise, you will get the wrong result. Okay, so 5 kilonewton, and the angle is 45 degree. Now resolve P1 and P2. You don't have to resolve P2. Still, if you want to resolve So what will you get? P1 sine 45 degree. Okay, and here what will be the value? P1 cos 45 degree. Okay, so if you write the equilibrium equation in this direction, in the vertical direction, the summation of Fy equal to 0. So P1 sine 45 degree plus 5 equal to 0. So P1 equal to what? Minus 5 divided by sine 45 degree. Here you have to determine the value of what? What value you have to determine? Tell me. Hello?
Yes, sir. P2, sir.
P2. Okay. So now write horizontal equilibrium. So summation of fx equal to 0. So what is the value? So cos P1 cos P1 cos 45 degree plus P2 equal to what? There is no another force. Okay. So 0. So P1 equal to what? Minus P2 divided by cos 45 degree. Now you can, oh sorry, you have to determine the P2, right? I have written P1. So you have to determine P2. So P2 equal to what? Minus P1 cos 45 degree. Now substitute P1 here. So minus P1 is what? 5 divided by sine 45 degree into cos 45 degree. And you have already know that the magnitude of sine 45 and cos 45 are same. So P2 will be what? Minus 5 kilo Newton. Okay. So here the result is what? Here it is asking the magnitude of the force. Okay, so there is no meaning of sense. Okay, the answer is only 5 kilonewton. If we talk, if we talk about the, I mean the sense, I mean what is the, I mean if the member is in compression or tensile, then you can say that here P2 is 5 kilonewton. So this sense is not correct. So you have to reverse this sense. So what is the correct sense? It is just reverse, and you have to write 5 kilonewton. If they ask the sense of the force in this member, then you can say that this member is in what? Compression. Okay, is there any doubt? Tell me.
Sir, P1 is minus sign, minus 5. No?
P1, yeah, I made this mistake here. Okay, 5. Okay, so the earlier sense is correct. Okay, sorry for the mistake. Anyhow, there is no meaning of sense here because it is asking about the magnitude. Okay, so member is in what? Tensile. Okay, is there any doubt? Ask me if you have another doubt. No doubt, so let's move. Okay, so since I have already talked about, I mean I've already discussed the method of joint, so let's keep the topic. What? Method of joints. So in this method you actually do what? We dismantle each what? Pin joint and each pin joint and members virtually. Okay, you actually do not I mean remove those members. Okay, so you actually realize only. Okay, then what will you do? Draw FBDs of each joint and what? Members. Then you will do what? Apply what? Equilibrium equations. Okay, so in this method you do these things. You will do these three things to solve the problem by using method of joints. Okay, so I have already given one sample problem, then I will do one, I will give one problem. Okay, so okay, so just move on the second method, then you will do the next problem. The second method is that is method of sections. So what is the advantage of using this method? In this method, you have to separate, each members, and the advantage of using this method is you are still able to find forces in all members, okay, and all reactions forces. But you have to separate all those members, and you have to apply equilibrium equations in all joints. Okay, so that is the disadvantage. Suppose you want to determine the force in a specific member. Okay, suppose you do not need to find all those forces in all members. You need only forces in a specific member. Okay, so for that purpose, you have to apply the method of section. So the biggest advantage of the method of section is, if if we need to determine the force, okay, in only one member, or in a very few members, then the method of section is most efficient. Okay, so suppose let's take one example. Suppose you have the situation like this. Here it is a pin joint, and here it is a roller joint. Okay, and there is a force P1, P2, P3, and there is another member. Okay, so here it is A, B, C, D, E, and F. Okay, so are you guys with me? Tell me.
Yes, sir.
Yeah. Suppose you want to determine specifically the force in this member. Okay, if you apply the method of joints, then you have to find forces. Suppose if we want to determine force in this member, then what will you do? You have to do you have to take this joint, and you have to determine force in this member, this member, this member. Okay, then you are able to determine force in this member. Okay, and for this also, I mean, for this force also, you have to find force on this member also, I mean, on this joint also. Because if you don't have the value of P1, you are not able to find the force in force member B. So for P1, you have to apply the equilibrium equation in this joint also. So the task will be very cumbersome. So if you apply the method of sections, uh, then the problem will be very handy. So what will you do? To apply the method of section, you have to do one thing. You have to virtually you have to draw a line. Okay, you have to draw a line such that the line will cross with three members, not more than three. I'm not saying that if you apply, I mean, you if you virtually draw line in four members, then I'm not saying that you cannot solve the problem. But still, on those all four members, you must have a value of one member. Okay, then you are able to find another three forces. Are you getting my point? Because if you separate, suppose I want to find the force in this member, and you are realizing like this. The force in this member is suppose FBD. The force in this member is FBE, and the force in this member is FCE. Okay, and here the force is P1, force is P2. Okay, so now you are realizing this thing as a rigid body. Okay, and for the rigid body you have only three equations. Okay, so if you have three unknowns, then you are able to find all those unknowns. But suppose you are separating, I mean, suppose you are realizing the situation like that, you have four unknowns. Okay, suppose there are another member and you have four unknowns, then you cannot solve the problem because you have only three equations and four unknowns. But suppose there is another member, suppose there's you are separating the section like that, you have four members, but in one member you have already the value, then you will apply the three equations and then you will be able to find unknowns. So that's why we talk about you have to separate the section such that you will cross only three members, so that you will apply three equations and you will find the value of three forces. Okay, are you able to get me?
Yes, sir.
Yeah, let's take one example what I'm talking about. Let's see. Yeah, let's see. No, not this one. Let's see one easy problem. Okay, let's talk about this. Can you solve this problem? Can you solve this problem?
Yes, sir.
Yeah, try this, then I will discuss it.
Sir, can you zoom it bit?
Yeah, okay, sure. Is it visible now?
Yes, sir.
Yeah, solve this. What is the answer?
20.
Yeah, okay, let's solve this. So to solve this problem, you have to forcefully apply, you have to apply the method of section, otherwise you will have so much difficulties. Okay, so what will it do? We have to determine the force in SR member. Okay, so I have already told you that you have to cut the section such that you will cross only three members. Okay, so let's cut this. Okay, if you cut this, then you will have what? There is a force FSR. Okay, and there is a force FRT, and there is another force FTQ, and so clear image. It's not so clear. Let's draw bigger one. You have
Sir,
the
is the answer 20?
what?
Is the answer 20, sir?
Yeah, it is a correct option. FTR, and it is a force FTQ, and here it is a member what? RQ. okay, and you have to determine the value of what SR. Okay, so what will you do? Now I'm considering this as a FBD. Okay, so if you want to determine FSR, what will you do? If I apply the moment equilibrium about this point, suppose if you want to apply the moment of, oh, one more thing, here there is another reaction force, I forget. Okay, you have to see, there is a reaction force, what, R1. Okay, now if you want to apply the moment equilibrium about this point, then you cannot determine the value of SR, because because this force is actually passing through this point, so there is no perpendicular distance. So you have to apply the moment equilibrium about this point, either this point or either this point. Suppose you are applying the moment equilibrium about this point. So what will you have? FSR into the perpendicular distance. The perpendicular distance is 1. Okay. Now these two forces are already passing through this point, so there is no meaning to write the moment for this force. Now the sense is this. Okay, and for this force, this reaction force, the sense is also in this direction. So what is the perpendicular distance for this? That is 1 also. Okay, now it is equal to 0. So if you want to determine FSR, then you have to find the value of R1. Okay, so now write FBD. Now draw FBD of the full structure. Okay, and you have to determine this reaction force. Okay, so now apply, there is another force here, 30 kilonewton. Okay, now there is no another force. Okay, now write the FBD about this point, about point P, and equate to all moment about point P equal to 0. Now if you write R1 into what is the perpendicular distance? 1, 2 and 3. Okay, and that is the sense in this direction. Okay, and for this force the sense is in this direction, so minus 30 into what is the perpendicular distance, that is 2, equal to what? 0. So R1 will be what? 20 kilo Newton. Now write R1 equal to 20 kilonewton here, then you will get equal to what? Minus 20 kilo Newton. Since it is talking about the magnitude only, so what is the force, what is the magnitude of the force in the member SR? That is 20 Newton. Is there any doubt? Tell me. If you want to, if you want to skip the method of section and forcefully you want to apply the method of joint, then you will have troubles. Okay, because you have to find all those forces for this joint. Okay, so that will be very
Yes,
time
sir.
consuming.
That would be.
Yeah, tell me, any doubt?
No, sir. By
Yeah,
that would be by at first we have to resolving forces
yeah,
of
yes,
this.
yes,
So
yes. Okay, so now let's move to another question. uh that is problem number this. Okay, it is a very straightforward question. Try this. Tell me what is the answer.
0.
0.
Yeah, it is a very straightforward. Let someone to try. Okay, let's wait for 1 minute, then we will discuss it. It seems like very difficult problem if someone does not know, the method of section. Okay, let's discuss it. So you have to find the magnitude of the force in the member CD. So where is the force, where is the member? This member. Now cut the section here. Okay, if you cut the section like this, then you will have three members. Okay, now draw the FBD. Okay, for these three member force. So here in this member the force is what? FBD, and for this member the force is what? FCD, and for this member the force is what? FCE, and here the force is 300 Newton. Okay, now you have to find the force in the member CD. Where is the member the force CD? Here. Okay, so here you can see very carefully. Okay, if you take the equilibrium about this point, moment equilibrium about this point, then you will have one advantage, and the advantage is the force FBD and the force CE is actually passing through this point. And the advantage is, if the forces are passing through the point where you are applying the moment about that, then the contribution of the moment about that point by those forces will be zero. Okay, so because there is no perpendicular distance for these two forces. Okay, so if you write the summation of moment about a point A equal to 0 and the contribution of moment by this force, you can see that the force is exactly passing through the point A, so the moment by this force equal to 0. Okay, now plus, now take FCD. Okay, so suppose I'm assuming that the perpendicular distance is this. Okay, so what is the moment? FCD into D. Okay, plus, now take the moment to contribution by this force, and this force is also passing through the point A, so that contribution is also what? 0. So FCD equal to what? 0. That's why the force in the member CD is equal to what? 0. This member was forceless. Okay, uh, is there any doubt? Tell me.
Yes, sir.
No, sir.
Yeah, what is the doubt?
No, no, actually, I don't have a such.
Yeah. So let's move to the another question. Now let's try this problem. Some people have already the answer, but still for others, let's solve this. Apply the method of section.
It's option C, sir.
Yeah, that is correct. What about others? Okay, so let's solve this. Okay, so one thing can be said clearly. That is what? Tell me. Without touching my pen, one thing can be said that these forces will be definitely zero. Those are what?
BF, GC, and DH.
Yeah, okay. So the force for the member BF, okay, force for the member BF is definitely zero because at this joint, Okay, at this joint, suppose the force in the member BF is like this. If you apply the vertical equilibrium, you will get what? Summation of Fy equal to 0. So Fbf equal to 0. And the same situation is for the member GC also. For member GC and for member DH. Okay, so what? BF, force in member BF and GC and what? DH, right? DH will be what? 0. So now what are the other options? And options are saying that you have to also check the force in the member CD and D also, and also FG and GH also. So where is CD? CD is here, right? And where it is D? D is here. So we have already the result, that is what? DH is already 0. So now let's cut the section here. Cut the section here. So, and then you will have what? You will have the situation like this, right? You have the force FHE, and here you have the force what? CE. CD, you can see that CD or CE will be same, because you know, if there is no force in the DH, so you can write CD or CE. So you have to write CD. And here there is a reaction force by this roller support, and that reaction force is directly along the member HE, and suppose that is R1. Okay. Okay, so now if you apply, okay, you can do one thing also, you know, you can cut the section here also. That is the more advantageous. If you cut the section like this, if you cut the section like this, then you will have more advantage. Suppose I'm cutting the section like this. Okay, then the situation will be very careful. I mean, suppose that force is FGH, FCH, FCD, and here the member is like this, and that member is like this. Okay, and here that is a reaction force R1. Okay, now you have to find the moment, I mean the force in the member CD. Okay, the force in the member CD. If you apply the moment about this point, about point H, so the moment about point H will be what? This force, this force, and this force are already passing through the point H. So the contribution of moment by these three forces will be already 0. But the moment contribution by this force is not equal to 0, because there is a perpendicular distance. So what is that? So if GH into 0 plus R1 into 0 plus FCH into 0 plus FCD into, suppose the distance is already given, that is 1. So FCD equal to what? That is 0, 0, 0, FCD equal to 0. So you will get the result FCD equal to 0. Now you have to check FDE. Okay, so if CD is equal to 0, if you draw the member here, the force in the member DH is already 0, so there's no meaning to write the forces by this member. Now you have already the force member CD equal to 0, and now the CD, FCD, and here FDE. So here FCD is already equal to FD. Okay, and the FCD is equal to 0, so FD is already equal to 0. But here the correct option is this. But now you have to check for FG and GH also. So where is FG? FG here and FGH. Okay, so now cut the section here, and you will see that if you draw FBD, okay, here FG, and here FC, and here FBC. Okay, so if you apply the moment, about this point, okay, you know, before applying the method of section, you have to choose the moment, about the point where you are considering the moment, you have to be very careful, because you have to take the advantage. If you apply the moment about this point, then you will not have the advantage. But when you apply the moment about this point, then you will have the advantage. Okay, so suppose I'm taking the point like this. Okay, I'm choosing the point like this, and that is what C point. And if you apply the moment about this point, then you will see that the moment contribution by this force and this force is already zero, and you will have the force only by this member, and there is two more reaction forces, that is R1 and R2. Okay, so when you apply the moment about this point, moment equilibrium about this point, then you will have what? F of Fg into perpendicular distance is what? 1. Okay, and plus R2, and what is the perpendicular distance? For that you have the perpendicular distance 2 meters. Okay, and the R1 is already passing through the point C, so there is no moment contribution, that is equal to what? 0. So you will have Fg equal to minus 2 times R2, and here R2 is not equal to 0, because you will have some definite value. So ffg is not equal to 0. If ffg is not equal to 0, then fgs is also not equal to 0, because that is exactly equal, because there is no force in the gc member. That's why this option is not correct, only this option is correct. Okay, are you able with me?
Yes.
Yeah, is there any doubt?
Yes, sir.
No doubt, sir.
Yeah. Okay, yeah, we have solved sufficient problems. Okay, so now we will wrap this session. Okay, in the next section we will discuss frictions. Okay, is there any doubt?
Okay. No.
Yeah, we will discuss
Sir,
friction.
we have some practice problems.
uh, Actually, I have already told about one book. Okay, I've
But
already told you about one book, and that book is, see this book.